Okay, so in this video we're talking about dividing polynomials. We're going to do two methods. First method is going to be synthetic division. Second method is going to be long division. And for both of these examples, I'm going to use the exact same set of polynomials. So the first thing you need to know though is when you divide one polynomial by another, you get what's called a quotient and a remainder. Okay? Now, when you're dividing a polynomial, you can actually think about this as you're cutting up a cake. So what you're dividing is your cake, and what you're dividing by is called your divisor. And that's kind of like how big of a slice is everybody at your party going to get. Your quotient is how many people can be served equally, and your remainder is kind of like how many crumbs are left over on the cake plate when you're done. So ideally, there's no crumbs left over, so no remainder. That way nobody gets in an argument over who gets the crumbs. So the first example I'm going to do again, I'm going to use what's called synthetic division. And synthetic division can only be used when your divisor is a linear term such as this. And it comes in the pattern, your linear term, or linear divisor, has to be in the form x minus a. Where this a is going to be our king. And it's what does the dividing. How big of a slice will everybody at the party get? So for this particular example, a equals 2. Okay, so what I'm going to do is actually set up my oven. Again, we're thinking about cake, so our slice goes on the outside and our cake goes on the inside. Now to get our cake, all I'm looking at is what's called my dividend, what's being divided. And I'm just looking for synthetic division just at the coefficients of the pieces. So, for instance, I have 1x cubed, 2x squares, 4 regular x's, and then 6 constants. Okay, that's not too hard. Now, I will say that if you were missing a piece, let's say there was no regular x's here, you would actually have to put a 0 as a placeholder. So, just like with a real cake, you have to tell it how many of each type of ingredient you have. So, if you're missing a piece, you must use a 0. Otherwise, this is going to get messed up. So now it's just a pattern. The very first thing you want to do is bring down the first number. So I just bring down the 1. Now the next step is to multiply. So 2 times 1 is 2. The next step is to add. 2 plus 2 is 4. And now we just start repeating. Multiplying, add. Multiply, add. For instance, 2 times 4 is 8. Now we add 4 plus 8 is 12. Back to multiply. 2 times 12 is 24. And then 6 plus 24 is 30. This last number is my remainder. These numbers right here represent the coefficients of my quotient. For instance, I started off with x cubed, so since I'm cutting this up into smaller pieces, the highest that this can be is going to be an x squared. If this was an x to the 4th, then the highest this could be would be x cubed, so on and so forth. So what this tells me is I have 1x squared plus 4x plus 12, and this is my quotient. Again, the quotient is how many people can be served cake in equal slices, so there's no argument. And your remainder is how many pieces of crumbs are remaining on your plate. Okay, so that's synthetic division. We're about to do the exact same problem, but using a method called long division. Now, remember with synthetic division, we had a specific type of divisor. The nice thing about long division, even though it is longer, is that it works no matter what your polynomials are. So let's go on to the next example. So example 2, again, we're doing the exact same polynomial, but this time by long division. Okay? And again, it does not matter what your divisor looks like. It could be any polynomial. So what we're going to do is set up our oven. Our oven looks a little bit different. And this will probably look very familiar to how you did long division in elementary school. Okay? So first off, our divisor goes on the outside. So x minus 2. And then our cake goes on the inside. So x cubed plus 2x squared plus 4x plus 6. And like synthetic division, if you're missing a piece, either in your dividend or your divisor, you have to represent it with a 0. I'm not missing any pieces, but if I were, I would have to put a 0 in as a placeholder. So now what I'm going to do is I'm looking at just the first piece of my divisor. So again, my divisor goes on the outside, dividend on the inside. I want to know how many times will x go into x cubed. If you need to do some scratch work on the side, you can, and use the laws of exponents. X will go into x cubed, x squared times. So x squared goes on top. I'm done with this scratch work. Now I'm going to take this x squared and I'm going to multiply it to both pieces of my divisor. So x times x squared is x cubed. X times negative 2 is negative 2x squared. Now, notice that my first pieces here, x cubed and x cubed, they match up. That's a good check to see that, hey, you're doing the right thing. If they match up, you're doing the right thing. So now, the next step is you want to subtract. X cubed minus x cubed will cancel out. 2x squared minus negative 2x squared is 4x squared, because negative and a negative makes a positive. And now we just repeat the process. So I'm looking for how many times will x go into 4x squared. So again, if you need to do some scratch work on the side, do some scratch work on the side. Some of you won't need to. So there's nothing to affect the 4, so that's just going to come out. And x will go into x squared x times. So plus 4x goes up top. I'm done with my scratch work. Get rid of it. Okay, so now, again, I'm taking my 4x and going to multiply it by both pieces of my divisor. So 4x times x is 4x squared. Okay, and then 4x times negative 2 is negative 8x. Oh, wait a second. What about these pieces? Well, if you remember from elementary school, you have to bring them down. So I have plus 4x plus 6. Okay. Now we're ready to subtract. So again, double check. These two pieces are exactly the same. That's what's supposed to happen, so that means I'm on the right track. So 4x squared minus 4x squared, like it's supposed to, is going to cancel out. 4x minus negative 8x is 12x. Because again, negative and negative makes a positive. And like we did before, this plus 6 just needs to come down. Okay, and then finally, last step. I want to know, and actually this was 12x right here. That's my fault. Now we want to know how many times will x go into 12x. So again, if you need scratch work, do it on the side. But this one's pretty obvious. It's just 12. Okay. So x will go into 12x 12 times. Now we multiply 12 times both pieces of the divisor. 12 times x is 12x. 12 times negative 2 is negative 24. Now we subtract. 12x minus 12x cancels out like it's supposed to. And then negative 6 minus negative 24 is positive 30. Okay, so our very last thing, 30 is our remainder. And then our quotient is up here. And since we divided the exact same polynomials, we did two different methods, it makes sense that we ended up with the exact same answer. Okay? That's it for this video.